Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is our video lecture over section 6.1. In this section, we're going to be talking about algebraic expressions and formulas. Big part of this chapter is just to get us prepared for future formulas that we're going to use later in the course, and we're just going to learn some things about algebraic expressions and then eventually plug those variables into formulas. So today we're going to evaluate algebraic expressions and use mathematical models, understand the vocabulary of expressions, and then simplify algebraic expressions. So algebra uses letters called variables such as x and y to represent numbers that could go into a formula, say. As an algebraic expression is a combination of variables and numbers using the operations of addition, subtraction, multiplication, and or division, as well as powers and roots. So here are some examples of algebraic expressions. I would call this x plus 6. This is x squared minus 6. This is 6x. And this is the square root of x plus 7, or root x plus 7. So the order of operations say that we need to perform the operations with the innermost parentheses and work outward. If the algebraic expression involves a fraction, treat the numerator and the denominator as if they were each enclosed in parentheses. Evaluate all exponential expressions next, and then perform multiplications and divisions next, left to right, and then additions and subtractions next, from left to right. Some of you remember, please excuse my dear Aunt Sally. Please is for parentheses, excuse is for exponents, my dear is multiplication and division, Aunt Sally is addition and subtraction. PEMDAS. So let's give an example here where we're going to evaluate an algebraic expression. We have this expression. It's 7 plus 5 times the quantity x minus 4 to the third power. And we're going to evaluate that for x equal to 6. So that means everywhere we see an x, we're going to plug in 6 and evaluate it. So the first step is to just plug in 6 right there. And we're going to work in the innermost parentheses first. So we're going to do 6 minus 4 and get 2. Then we're going to take 2 to the third because that's the exponent. 2 to the third is 2 times 2 times 2, which is 8. And then we do the multiplication, 5 times 8, which is 40, and the addition last to get 47. We're sometimes going to plug things into formulas. So just to go over some vocab, an equation is formed when an equal sign is placed between the two algebraic expressions. A formula is an equation that uses letters to express a relationship between variables, two or more variables. And mathematical modeling is the process of finding formula to describe a real-world phenomena. So a lot of times we have formulas that describe mathematical models, things like that. So here's an example here. The bar graph shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. The mathematical model, W, equals negative 66x squared plus 526x plus 1030 describes the number of calories needed per day by women in age group X with moderately active lifestyles. According to the model, how many calories per day are needed by women between the ages of 19 and 30 inclusive with this lifestyle? Because 19 and 30 is described as group 4, that's this one right here, group 4. We're going to substitute 4 for x, into the equation. So the first step is just plugging in 4. Alright, so when we look at this line, we have to do our exponent first. So that's what they did here first. 4 squared is just 4 times 4, which is 16. Then we can do the multiplications from left to right. We'll do the additions last. So negative 66 times 16 is negative 1056. 526 times 4 is 2104. And then we can do the additions from left to right, and we get 2,078 calories. The formula indicates that 2,078 calories are needed per day by women in the 19 to 30 age range with a moderately active lifestyle. Some more vocab for algebraic expressions. The number of terms, this is not something we'll specifically ask a lot, but just so you know, the number of terms in algebraic expression are things that are separated by pluses and minuses. So in the expression 7x minus 9y minus 3, there are 3 terms. The numerical part of the term 7 and negative 9 are called coefficients of the variables. So when we have a number times a variable or in front of a variable, we call that a coefficient. So 7 is a coefficient and negative 9 is a coefficient. And then the minus 3 is called the constant term when we have a term that's just a number by itself. Like terms are terms that have the exact same variable factors, so 7x and 3x could be like terms. And factors are part of each term that need to be multiplied. So sometimes we'll combine like terms. So this one says simplify an algebraic expression. We want to simplify 5 times the quantity 3x minus 7 and then minus 6x after that. So the first thing to do is actually use the distributive property, because 3x minus 7 we can't combine anything within the parentheses. So we're going to multiply the 5 times both of these terms and distribute the 5 is what we say. So 5 times 3x minus 5 times 7 minus 6x. So then we'll do 5 times 3x is 15x. 5 times 7 is 35 minus 6x. And then we're going to combine like terms. 15x and minus 6x will give us 9x, and 9x minus 35. So this is some basics over algebraic expressions of evaluating. When we plug in a variable, we're evaluating, and simplifying an expression is just combining, doing the math and combining as many terms as you can until you're at the end. So good luck. We'll see you next time.